All right. So remember yesterday, okay? Yesterday we talked about having a polynomial function in standard form, highest degree down to the constant. Leading coefficient is the coefficient out front. The degree is the highest exponent of the variables, okay? We talked about naming constant. Degree of 1 is linear, 2 is quadratic, 3 is cubic, 4 is quartic, and 5 we added was quintic. Then we went to determine whether or not the function is a polynomial function. In order to be a polynomial function, it has to have real number coefficients. So just the coefficients have to be real numbers. They can't have i's. And you have to have whole number exponents. 1, 2, 3, 4, 5, so on. So yes, it's polynomial, write in standard form, give the degree, the type is cubic, and the leading coefficient. We did the same thing here. This one looked funky, but it was a polynomial function because the square root of 2 is a real number. The degree is 4, leading coefficient square root of 2, it's quartic. This one was not because you can't have a negative 1 as your exponent because it's not a whole number. And this one wasn't because the polynomial x, the exponent x could be anything. Then in this one, evaluate when x is 3, we just plugged 3 in and evaluated. Then we discussed and talked about if we have a linear function that is positive, it goes up to the right, negative, it goes down to the right. If we have x squared that's positive, they both go up, negative, they both go down, and that is true for any even or odd polynomial. And then positive or negative leading coefficients. So then we talked about end behavior. If it's odd, they go in opposite directions. If it's odd and positive, it goes up to the right. Odd and negative, down to the right. The end behavior will always start out as x approaches positive infinity, f of x approaches what? So you just ask yourself as you go out towards positive infinity, which way is your graph going? Positive. And then as x goes towards negative infinity, it's going down. Same thing here and here. So that was yesterday, and then we did 3 of those type of examples. Ask yourself, is it in standard form? It is. What's the degree? 4, that's even. Leading coefficient, negative. So we said even and negative, they both go down. So you can figure out your end behavior. All right. Now we're here. This is where we are now. Graphing a polynomial function. So when you graph a polynomial function, we're going to plot enough points to determine the shape of this graph. So let's just kind of take a look at this. Is it in standard form? Yep. What's the degree?
3.
The degree is 3. What's the leading coefficient? Negative. So we have odd and negative. So what can you guys tell me about the end behavior? Odd means they're going in what? Opposite. And negative means up to the right or down to the right. So we know it's going to do something like this. Okay? And I just keep that in mind because I know the ends of my graph have to go in that direction. Have to go in that direction. So we're going to make a quick table of values. Now, you guys will not have graphing calculators for every single one of these, so don't think I'm just going to type this in my graphing calculator. Let's start with this table of values. Okay, if once you put this into your graph or onto the graph, you don't see the whole end behavior, you have to go further to the left or further to the right. I'll show you what I mean in a minute. So on your calculator, because I would give you red calculators, I'm going to do negative 2 to the third. Plus, make sure you have your negative 2 in parentheses. Plus, darn it. Negative 2 to the third plus negative 2 squared plus 3 times negative 2 minus 3. And when you do, what do you guys get for an answer on this one? Did you guys get 3? Now, I want to show you something kind of cool that you can do on a graphing calculator that a lot of you did not know. Are you ready? After you get that entered. Did you guys know on the newer calculators, you can just use the up arrow key? On my calculator, I have to go second. God bless you. I have to go second in entry. Do you see entry? It'll re-put that entry in. And now I can just come up and change all my -2's to -1. So that is one thing you can do if you want to not have to recopy it all. So again, that was second entry, or you go up and get it. And what do you guys get for -1? -4. Now, 0, you should not have to put in your calculator. Because if all the x's are 0, they go away. What's your answer? -3. Okay. The 1, when I change from a negative to a positive, I usually start over. So -1 squared, not squared, raised to the 3rd, plus 1 squared, plus 3 times 1, which is just 3, minus 3. Now, what do you guys get there? Did you get 0? And now, to get the second one, I'm going to go second entry and change all of these to 2. And what do you guys get for 2? You get -1? All right. Any questions at all on how I got that table of values? All right. Now let's graph these points. I'm going to go over -2, up 3. I'm going to go over -1, down 4. I'm going to go over 0, down 3. Over 1, up 0. Over 2, down 1. And it helps that you know your end behavior, because the end comes from the upper left. So it's going to come this way, go down, up, and down. Now, do I know the exact heights of these humps? Nope. Those are called local mins and local maxes. We will get there with those. We're not there yet. But between this table of values and your end behavior, I can get the general curve of this graph. Now, if we knew this was supposed to come back up, maybe this was a positive with an even, and you know it was supposed to come back up, you would have to go out to 3 to get that next point to see where it comes back up. So that's what I mean by extending that table of values if you need to. Okay? Let's try one more. So let's look at this one. Even or odd? Positive or negative? So what can you guys tell me about the ends? Both going up. Some people put their hands up. Some people said it. So we don't care what happens in the middle. They're both going up. So keep that in mind. Let's make a table of values. And let's start with -2, -1, 0, 1, and 2. Again, when you put in -2, make sure you put it in parentheses. What'd you guys get for -2? You guys get 12? Okay, finish the table. All right. Are we done? What'd y'all get for -1? Everybody. 2. How about 0? 4. How about 1? 0. How about 2? Okay, so now let's go ahead and plot these. So I'm going to go over -2, up 12. So I had to go up a little bit further. I had to extend this. That was 10, 11, 12. Then it went over 1, up 2, over 0, up 4, over 1, up 0, over 2, down 4. Now, the only thing is, if I look at this, I don't quite have it all because watch, I'm coming down and then up and then down, but then I'm not really sure, right? And we know it should curve back what? But let's try. So put in what? This is where you go a step further. Add 3. Because you got to see where this curves. So when you put in 3, you got what? So like 22 is like way up here, right? So it shoots like way up. Okay? Questions? So use the chart with your end behavior. Do not use your graphing calculator because you will not be allowed to use your graphing calculator on this part of the test. Questions? All right, now I do want to show you one thing because the online book, I need you to just look up here for 1 second. All right, the homework tonight is 2 through 14 even, 18 through 21 all, 26 and 30. On number 18, the online book is missing D squared. So I'll leave this up here so that when you get to it, you can see it. But number 18, it just says D. It doesn't say D squared. So just make sure when you get to number 18, this is the formula you need to use. I will leave this up for those of you while you're working. All right, we have the rest of class time to get busy. Is not what I wanted.